Hi everyone, I'm Janly Enerio.
I am Ronald Soriente.
And I'm JP De Vera.
In this video, we are going to discuss all about the antenna.
Under this discussion, different types of antenna including system will be tackled.
And in addition, advantages and disadvantages, including the applications of each antenna, will be briefly explained.
Antenna system. The antenna system is one of the most crucial areas in a radio access network. The performance of the component in the antenna system ultimately determine the effectiveness of the radio site, while a poor antenna system can severely reduce the radio network performance.
Log periodic antennas. A log periodic antenna is also named as a log periodic array. It is a multi-element directional narrow beam antenna that works on a wide range of frequencies. This antenna is made of series of dipoles placed along the antenna axis at different space intervals of the time followed by a logarithmic function of a frequency. Bow tie antennas. A bow tie antenna is also known as a biconical antenna or butterfly antenna. Biconical antenna is an omnidirectional wideband antenna. Log periodic dipole array. The most common type of antenna used in wireless communication technology is a log periodic dipole array. Fundamental comprises a number of dipole elements. These dipole array antennas reduce in size from the back end to the front end. The leading beam of this RF antenna comes from the smaller front end. Wire antenna. Wire antennas are also known as a linear or curved antenna. These antennas are very simple, cheap, and are used in a wide range of applications. These antennas are further subdivided into four explained below. Dipole antenna. A dipole antenna is one of the most straightforward antenna alignment. This dipole antenna consists of two thin metal rods with a sinusoidal voltage difference between them. The length of the rods is chosen in such a way that they have quarter length of the wavelength of operational frequencies. These antennas are used in designing their own antennas or other antennas. They are very simple to construct and use. Short dipole antenna. It is the simplest of all types of antennas. This antenna is an open circuited in which short denotes relative to a wavelength. So this antenna gives priority to the size of the wire relative to the wavelength of the frequency of operation. Monopole antenna. A monopole antenna is a half of a simple dipole antenna located over a grounded plane as shown in the below. The radiation pattern above the grounded plane will be the same as the half-wave dipole antenna. However, the total power radiated is half that of a dipole. The field gets radiated only in the upper hemisphere region. The directivity of these antennas become double compared to dipole antennas. Loop antenna. Loop antennas share similar characteristics with both dipole and monopole antennas because they are simple and easy to construct. Loop antennas are available in different shapes like circular, elliptical, rectangular, etc. The fundamental characteristics of the loop antenna are independent of each shape. They are widely used in communication links with a frequency of around 3 GHz. This antenna can also be used as electromagnetic field probes in the microwave bands.
Traveling wave antennas. Helical antennas. Helical antennas are also known as helix antennas. They have relatively simple structures with 1, 2, or more wires, each wound to form a helix, usually backed by a ground plane or shaped reflector and driven by an appropriate feed. The most common design is a single wire backed by the ground and fed with a coaxial line. Yagi-Uda antenna. Another antenna that makes use of passive elements is the Yagi-Uda antenna. This type of antenna is inexpensive and effective. It can be constructed with one or more reflector elements and one or more director elements. Yagi antennas can be made by using an antenna with one reflector, a driven folded dipole, active element, and directors, mounted for horizontal polarization in the forward direction. Microwave antennas. The antennas operating at microwave frequencies are known as microwave antennas. These antennas are used in a wide range of applications. Rectangular microstrip antennas. For spacecraft or aircraft applications, based on the specifications such as size, weight, cost, performance, ease of installation, etc. Low-profile antennas are preferred. These antennas are known as rectangular microstrip antennas or patch antennas. Planar inverted F antennas. A planar inverted F antennas can be considered as a type of linear inverted F antenna (IFA) in which the wire radiating element is replaced by a plate to increase the bandwidth. The advantage of these antennas is that they can be hidden into the housing of the mobile when compared to different types of antennas like a whip, rod, or helical antennas, etc.
Parabolic reflector antenna. The radiating surface of a parabolic antenna has very large dimension compared to its wavelength. The geometrical optics, which depend upon rays and waveforms, are used to know about certain features of these antennas. Certain important properties of these antennas can be studied by using ray optics, and of the other antennas by using electromagnetic field theory. Corner reflector antenna. The antenna that comprises one or more dipole elements placed in front of a corner reflector is known as corner reflector antennas. The directivity of any antenna can be increased by using reflectors. In case of a wire antenna, a conducting sheet is used behind the antenna for directing the radiation in the forward direction.